Hello again. This time we thought we'd have a tackle at subfloors and subfloor problems. So again, today's agenda, we would suggest that by the end of this presentation everybody should have a basic understanding of basic subfloor construction, methods of measuring RH or relative humidity. You will hear that one a lot. Use of damp-proof membranes, detailing and use of adhesives, welding techniques, and then we put in there one of the things that can happen where you get shrinkage, so why shrinkage happens and how you can prevent it. Types of subfloor. This is not an end list, there are more types of subfloors than this, but these are the most common ones you'll come across. So we have sand cement screeds and power float screeds, granolithic, timber, terrazzo, metal, timber planks, chipboard and plywood. Normally most floors start out with a plastic membrane, sometimes it's called visqueen, and this material is spread across the floor over the existing oversight concrete, which is the first layer of concrete to go down. This provides the damp-proof layer. Obviously this has got to go down in one piece and any joints have got to be securely put together and it mustn't get punctured. A concrete base can be installed at different thicknesses, but in almost every case a latex top will be required before the installation of any floor covering. Think Ardex, think oozing of the screeds available. Interestingly, if you look at pictures 1 and 2, you can actually see the visqueen where it comes out from under the floor and it's been taped to the wall whilst the floor is installed. The third picture is the latex top going on as a smoothing compound. Power float is basically a concrete floor laid in the same manner as the ordinary floors, but to give it extra toughness, this machine is imagine it as an upside down helicopter. It's run over the flooring, and as you can see it creates the swirl patterns, but what it does do, it closes the surface of the concrete, brings the moisture and latency to the surface, and when it dries it's extremely hard. And you might think, where would that be used? Well, think of Altro factory where we have forklifts running around that may weigh 4 or 5 ton. Obviously a normal concrete would break up, a power float won't. And Hydrite, becoming quite popular, they've always been very popular in Europe. They are usually a water-based system and they contain lots of things like plaster type derivatives and sometimes waste product from power generation stations. Interestingly again, the guy can lay no end of this material through the end of a hose, which is probably outside connected to a pump somewhere, and then he can actually ride this pipe, walk up and down with it and fill up an area. Those little stands that you can see, they are to give thickness, so as this guy is going around with his hose pipe you can see how much he's actually installing and get it to the right thickness. Has lots of advantages, including things like it doesn't crack, you could put down several hundred meters a day, doesn't shrink, whereas concrete floors tend to do both of the above. However, it doesn't dry any quicker than normal. So, testing for relative humidity. In the UK and Europe, floors should be tested for RH, relative humidity, prior to the installation of any floor coverings. So for example, a subfloor can take 1 millimetre a day to dry. So if you have 90mm screed, it's going to take 90 days to dry. Power floats, because of what you've done to it, closing the surface with the machine, can take actually longer. And I think the guy on the right hand there is, I hope he gets out there before he gets set in there for life. So in the UK we use methods of measuring relative humidity. If anybody ever wants to see any of these machines, we do have a stock of them upstairs in the training school. This is a hygrometer. They're reasonable cost, they're just a foam box that you stick to the floor. And they're mainly used in the UK to measure dampness in the subfloor. They give quite accurate readings, however they need to be attached to a floor for 7 days. Easy to calibrate, and they measure relative humidity, and the requirement for all our subfloors in the UK, which is a British standard requirement, is 75% or less. As you can see from the little gauge in the hygrometer there, it's actually at 96%. One of the disadvantages of these, if you stuck a load of these to a building site, you'll come back and half of them will have been destroyed, kicked around, used as football or jumped on. So this is the disadvantage. This is what technical services in the UK use. Slightly destructive insofar as on the right hand side you can see some yellow, almost like raw plugs. They have to be drilled into the floor, and then there's a cap which goes on top. That is secured on there, and then they have to be in for 24 hours. And then what happens is that you come along after fitting the pellets into the floor, and then you can attach the hygrometer through little sensors, and they give you, in half an hour, they give you a very, very accurate reading of what's going on. And as you can imagine, they are much better for not hitting damage on building sites, as long as the caps have been left intact. If the caps have been taken off or broken, then they have to be placed on. You can't take a reading. So they're mainly used in the UK, much more portable than a hygrometer. However, will require the sleeves to be fitted to the floor, so somebody's got to drill holes in it. Multifunctional, can be used on walls. A reasonable cost, and when I say reasonable cost, when you think of the cost of a job going wrong, that's when this thing really comes into its own. Measures relative humidity, again RH, and there's a requirement of less 75%. It has several different modes, can be turned on to different modes for measuring for white rock. Mainly used in Europe is the carbide bomb. Sometimes you will have to use this several times in one job, and as you can see again on the right hand side you've got two hammers, so that gives you an indication that what you actually have to do is you have to break a piece of the subfloor out, and there's lots of weighing of it and all sorts of things. The reason it's called a carbide bomb is that you put your measured sample of concrete into that vessel with the gauge on top, you drop in some ball bearings and a file of the carbide, shake it, the ball bearings break the carbide bombs, and that then gives you a very accurate reading on the dial on the top. The trouble is, if you have to keep going back and back to the same installation, or it's a very large installation, it takes a long time. Slightly different way of measuring it, we are still looking for 75% or less, but this correlates roughly to a less of 2.5% water content. Anything above, by the way, of any of these RH readings, you need to start looking at DPMs. DPMs extended to brickwork. That's an interesting point. When you go home tonight, you will probably start looking around your outside of your house. At some point, about 2 or 3 bricks above the ground that you can see, you may see a dark line, and that dark line is the DPM that's gone into the brickwork. The idea is obviously that you don't want damp travelling up and going up into the walls. Incidentally, a lot of public buildings and housing never had DPMs installed until about the 70s. Damp-proof membranes, DPMs. They're widely available, they're used around the world, and they're now widely used because of the speed that the installations are put up and occupied. You may have noticed yourself that you drive past a building site on Monday, there's a big hole in the ground. By Wednesday, Thursday, the building structure is up, and within 2 weeks people are moving around inside. That's not giving the floors a chance to dry. So, Altro have Ultraproof Universal, Ultraproof Fast Track, Everlay A and B, and of course also now we have Express Lay and Wood Loose Lay. This is a handheld protometer, and the only reason I put this in here was because this was actually a job in France. It's a real job. It was a very, very large installation in a supermarket, and as you can see from the handheld protometer, which uses a traffic light system, the floor was well into the red, which was obviously danger, but somebody went ahead and laid the floor, and throughout the entire job the picture on the right hand side is what the customer ended up with within 6 months. This clearly shows the power flow concrete and what's happened. The very damp power flow screed, preparation has washed away, so even the screed has gone, and the adhesive has emulsified. This adhesive would have been yellow in colour originally, and it's gone to white, gone very, very thin, and started squeezing out through the joints, and eventually just went to powder. One of the problem subfloors you may come across from time to time is one called magnesite. Magnesite is a very strange material. It has wood chips in it. One of the disadvantages of the wood chips in it is obviously if you cover it over, as you can see by the picture on the left, Yeah, that's only just the carpet. What can happen is the material can soak up wood from the air, the moisture, and from underneath. It will start to swell and it will start to break up, which is what the picture on the right shows. Unfortunately, there is no cure for magnesite. If you come across it, it has to be removed. There is nothing we can do with it. You cannot use DPMs, you cannot cover it over. If you ever see this stuff, one of the best ways to find out is put your hand on it. It sometimes feels a little bit warm. It has wood chips in it, and I wouldn't advise this doing in front of anybody, but if you take a small piece of broken magnesite, hold a cigarette lighter underneath it, you may be able to smell sort of a bit of burning wood going on. That's the tiny chips of wood actually burning within it. Obviously, discretion here. You don't want to do it in front of a very worried customer. But again, just to reiterate, there is no cure for magnesite. It has to be removed. Timber planks. We've all got these in our houses. Some have got boards, but generally it's floorboards. We can deal with these. The floor will need to be plied over with a minimum thickness of 6mm plywood. Decent quality plywood as well if possible, and there's a pattern of nails which is usually every 4 inches. A lot of nails or staples go into these floors. There are compressors and stuff to make life easier. If you don't, eventually the floor will conform to the shape of the timber planks, and if the timber planks are cupped or bent as they normally are, that will show through. Chipboard, we get asked a lot about chipboard, and if you look at the picture you can see that the chipboard surface is a very pale green colour. That's because what's happened is that the chipboard itself has been treated to resist moisture, because a lot of this stuff gets dumped on building sites and they don't like it getting wet because it spoils it, so they put this coating on the top. So if you think about it, if it's got that sort of coating and it resists moisture, adhesives work by soaking into wood, therefore it's not going to soak into this, so therefore you've got to be looking at again overlaying with plywood. If it's not moisture coated, then obviously you can, but it's very important that you check all the joints and stuff to make sure that they're not raised up in any way, because again it will show through. So general rule of thumb is you can get away with it, but it's probably always best to use plywood. Plywood itself, this picture shows, it comes with lots of different thicknesses. Plywood itself is a very good medium to put floors over, and it's a very good medium to put over problem floors. This is what they call OSB. This is oriented strand board. We get asked a lot about this material, and sometimes people have made it up for subfloors. It's really not the best stuff at all, and if you come across this particular material, it's best to remove it. If you can't remove it, or it can't be removed, then you've got to be looking at plywooding over the top, but with a really good substantial thicker plywood. Steel checker plate. All steel floors can be overlaid, but were required to be free of dust, rust, paints, etc. So it must be clean and bright steel. So it could require extensive preparation. If you look at this particular picture, you'll see this sort of steel plate all over the place, including the emergency staircases, etc. There's no reason why you can't put floor to them, but they will need to be very heavily flattened first. Granolithic. Find this in older type of buildings now, not so popular anymore, but more cement based than terrazzo, can be laid with texture to provide slip resistance. Granolithic now can also be formed in the way of resin floors, but the original granolithic was actually a cement based. Terrazzo, much more colourful usually than granolithic. There's generally more aggregate in there, and it's usually marble to give a really nice effect. Again, when it's all shined up, etc., it looks really nice, but it's got to be kept clean. We thought we'd include a little patch on welding in here because obviously it's an important thing. So welding creates a waterproof seal between two pieces of flooring. It also creates a permanent bond and becomes part of the floor itself. There are two types of welding available: hot weld, which is what we advocate here, we do on the training school, and this is universally across the world. Cold weld, which is a chemical process, slightly niche application. Some of these chemicals can be very, very good and they work very well, but there are some health and safety issues because some of the chemicals in some of these material is pretty nasty. So you need to read labels very carefully, but 90% plus in the UK it's hot welding. So to create a good weld with ultra safety, what you need to do is groove the material first to 60% through the material, collect the correct temperature on the welding gun. When you're moving the welding gun, not too fast, not too slow. I know that sounds a bit odd, but a reasonable pace. But we always recommend that you do a test piece first of the material you're using, and that will give you an idea. If you go too slow, you'll burn. If you go too quick, it will not actually work. Trim the weld twice. There is a spatula specially designed to cut welds, and it has a sledge that you use first, which then takes off the majority of the weld, and then you pass a second go with the knife or spatula only, and that takes the weld down to the surface. So then we go on to the main cause of shrinking, which is damp. So ignoring a damp subfloor is never a good idea. It really isn't. Just as a matter of interest, it can actually cost you a small fortune to put a job right, just for the sake of not applying a damp-proof membrane. Because obviously you've got the existing floor which is now ruined, you've got to supply new material and get that installed. You're only going to be paid for one job, and then of course you've got uplift and disposal. So it's actually roughly about 3 times the cost of your original job to you if it goes wrong. So why ignore it? How does shrinkage manifest itself? Well, joints can start to break open, material shrinks back from each side of the weld, near door frames, around drains, etc. Most of us by now have seen pictures of this. And then of course, vicious circle, more water ingress leads to more damage and shrinkage. Problems will get worse. It can be repaired, but it will never look quite right. The picture on the right, by the way, was actually a job that was seen not so long ago, and you can see how much it's actually shrunk. And if you look down the weld, you can see that the right hand side was still attached, the left hand side has come completely off, mainly because it wasn't welded properly. It was also the wrong type of adhesive was used, and it's gone, it's been washed away. So how to stop it? So at the very start, you must really measure moisture content in the subfloor. Apply a DPM if required, up to 25% installations. That's only a rough guess, but they will require a DPM. And if you think about it, you're not paying for the DPM, the customer is, but if it goes wrong, you'll be paying for it. So they need good detailing, such as clamp down drains, good installation techniques, correct procedure for welding, and the use of polyurethane adhesives where required, especially in wet areas or kitchens, anywhere where there's going to be a lot of strain on that floor. After installation, we recommend cleaning chemicals at the right solution or dilution, because they can extract plasticizer. We've seen this before, where somebody's used a particularly vicious cleaner on the floor, and eventually the floor will start to go brittle, and it will actually remove the plasticizer from the floor. Use correct cleaning methods. Altro produce a whole range of cleaning cards just for this, pictorial and wordy, and they go in and tell you exactly what you need to do. Our response to claims is, unlike other companies, we have technical services which will investigate issues on a case-by-case basis. Altro staff on ground to gather as much information as possible. So in other words, telephone call comes in, we get the information, and we need as much information as we can. There's not really every single justification, every case is different, but common issues are damp. There's no standard response, and as multiple root causes, but if technical are involved, then obviously we will get to the bottom of it. Always raise a CCR, because on there you can put lots of details that you get at the time. In Nordic countries, for example, water-based acrylics are used in areas where in the UK we reckon that they must use a polyurethane such as A19. The reason for that is because their welding is subject to rigorous testing. This rigorous testing ensures that moisture does not penetrate the welded joint and attack the adhesive. In the UK we tend to be not so good at welding, which is why we recommend the adhesives. So the quality of welding in some parts of Europe is not at the same standard. Before installing the flooring using any adhesive, the flooring must be laid flat to relax, overnight if possible at room temperature. This helps remove the tension from the product. It also conditions the material to make it easier to install. And obviously it goes without saying, if you see any faults, tell us. Thank you.